Hello everyone, my name is Georgios Digkas. I'm currently a PhD student in the University of Groningen and University of Macedonia. So I studied in Greece. I did my bachelor and my master there, and then I moved to the Netherlands and over there, on the north, there's one small village which is called Groningen, in order to start my PhD. So I spent the first 2 years there, and now I'm back to Greece for my second 2 years. I was collaborating with my supervisors at Professor Paris Argeriou in the Netherlands and Professor Alexander Georgiou in Greece. The title of my project is Data-Driven Analysis of Technical Debt based on open source projects. Now, what is technical debt? I think this picture describes it really good. Technical debt is a metaphor that was coined by Ward Cunningham in 1992. Basically, when we would like to implement a new functionality to one project, we have two ways. The first one is to design it properly. This one will take much longer, but in the future it will be easier to maintain and to extend the feature set of the project. The second one is it's called the quick and dirty way. We do the things as fast as possible. We just check that it runs, and then we move to the next one. This one, the second way, in the future will slow us down because we didn't design it properly. In the literature, here we can see some symptoms of technical debt. For example, duplicated code, mishandling exception, or there's one list of things. Actually, there are many tools in the literature like SonarQube, Score, Q1, and Cast that detect the technical debt into one project. And this one is the mapping literature, a mapping study by Zheng-Yang Li that describes all the methods and all the tools that are available that can detect what different types of issues of technical debt can detect. For my studies, so far I have 2 papers, I relied on SonarQube way because it's an open source and it's free to use. How SonarQube works? It relies on one set of rules, and every time it analyzes one project, if one piece of code breaks one of the rules, it raises one issue, it assigns one estimation on how much time it will take us to fix that issue. Finally, in order to calculate the technical debt, it sums up all those issues and presents the technical debt in 1 day. Here is one screenshot. As we can see, I have analyzed one of the projects. The estimated technical debt for this issue is 10 minutes. Here it describes its ability related to the architecture. Every time that it detects this one, it's constant. It assigns 10 minutes. And also it classified them based on the severity in those 5 categories: blocker, critical, major, minor, and info.
Is that a real one, the interface, like 10 minutes step? Is that a real one or something speculated? I mean, the interface.
Yeah,
it's really what it says. I mean, the 10 minutes is a speculation how much it would cost.
So
it's a prediction.
So the current interface is now like Jira and the Maven link and those, the project management stuff. Do they have something like this in them? The current tools like Jira, Maven link, those tools for project management, when you have tasks and resources allocated and time and so on, do they have like that as well at the time? Or?
I'm not that familiar with those tools, but I have heard that Jira has started to include something like that technically, but I'm not sure. So
but this one is real. This one.
Yeah, this is actually a screenshot from SonarQube.
But SonarQube is a static analyzer.
Yeah,
So
it's a static
it says we think it will take you 10 minutes to
Yeah,
fix it.
it's
Not,
a- it is-
it doesn't create a bug for you
Actually, I have
if you don't want it to.
one. Let's see. So this one is one instance that runs on my computer, and I have analyzed one project. It says that it has detected 26 bugs, 3 vulnerabilities, and 307 code smells. The size of the project is about 10,000 lines of code. And here we can see what are the different issues. So it's it's pretty similar, and yeah, the estimation is about 30 minutes.
Is this one which kind of project? Is it a product software?
It's,
or it is
it's,
a
Apache library.
it's
yeah.
Apache library, yeah,
Okay,
it's called
I see.
Apache
Yeah,
Commons IO. Yeah, I don't
No variable quality.
Yeah. So the first study that I quoted was the title of the study is the evolution of technical debt in the Apache ecosystem. Actually, I would like to know what are the most frequent types of TD, what are the most costly to fix, and how technical debt evolves over time. In order to answer the previous questions, I chose to analyze Apache project because it's one of the biggest communities out there. It provides software for public good. All of them are highly appreciated and they are open source, so it means that I have access to the evolution and also on the source code. So on this one, after analyzing about 55, 60 projects, I ran the man-Kendall test in order to detect if there is one trend on the technical debt. If the bars are above those two gray horizontal lines, it means that there is one trend. If there is positive, it means that here's upward trend. So in other words, the technical debt tends to increase over time. For those projects, there are about 6, 7 projects, the technical debt tends to decrease over time. For those two, I checked what was going on, why the technical debt was decreasing, and I figured out that the code basis was shrinking. So the guys was removing their code. Maybe they were maybe they were using a library instead of their code. But for the majority of the project, technical debt tends to increase. Then I want to know how the normalized technical debt, in other words, the amount of technical debt that exists on each source line of code, evolves over time. And here the things are the opposite. For the majority of the project, I saw that the normalized technical debt tends to decrease, which is surprising if we if we take into account Lehman's law, which says software tends to age over time and the quality goes back. Here those are the top 10 most frequent types of issues that exist on those projects. As we can see, there are many of them, about 10% are related to code duplication. Another 10%, roughly 10%, it's related to exception handling, and I forgot to highlight those. And those are also related to the complexity of the code. then I sum up all the estimation that SonarCube made, that how much time it will take us to fix all, let's say, for the duplications, all those issues. For the duplication, it will take about 22% of the technical debt on those projects are related to source code duplication, and then about 12% on the complexity of the code, and then another 20% related to exceptions. So those are how many hours it will take someone to pay back the technical debt. That is, they need 672 hours to pay those back, according to SonarCube's estimations. So the takeaways of that study is that technical debt tends to increase over time for the majority of the project. The normalized technical debt tends to decrease over time. The most frequent problems are low-level coding problems, and the most expensive are duplicated blocks of code and ad hoc exception handling. Maybe for the exception handling, one reason is maybe the exception handlers that Java uses are difficult or limited. Yeah. Finally, a minority of the problem times is responsible for the vast majority of the project, as I show here. For example, those are two. If we sum up those top 10 most frequent issues are about 40%, I would say.
May I comment? Ask about the method here. About if you go to the cognitive stuff, it is the most difficult part to fix.
This one.
How was that measured? I mean, how was the percentage concluded there? What was the type of study that you did?
Oh, this one.
The percentages. Where did they come from?
Okay, this is the 5% of the total amount. I sum up all the technical debt of all the projects, and the technical debt that is related to the cognitive complexity accounts for the 5%.
I understand. How you judge? How did you make the judgment that this technical debt is related to cognitive complexity? This one is related to, because that's the
okay.
SonarCube does.
SonarCube does. So if I go here, then issues, then rules. Those are. I relied on those rules. So
I think your slide didn't move.
Yeah.
Oh. Also.
Oh.
No, before you.
Okay.
Oh, you're trying to.
So let's say if I click, those are the things that I list there.
No, it's fine, but I would doubt their method as well. I would have doubts and also question their method, how they classify the technical debt, whether this is related to cognitive complexity or to the other. The method they also apply to make that judgment. So they have a method to classify, to say this technical debt is related to cognitive complexity.
Yes.
But how they do that?
How nested are your ifs? How many nested your if statements? How long is the method? Those kind of metrics you think about.
Okay, that's clear now.
Okay.
But it does give the limitation, like there's a lot of technical debt that a tool like SonarCube just cannot detect.
It's the problem with cognition is really depends on the person, isn't it? So some people are good at the nesting stuff, the parallel stuff. Some people are not. Serious. Having a normalized way to say that is.
But your source code should be also working for the less talented co-workers.
Yeah, you say the average. Yeah.
The cognitive complexity is completely different from cyclomatic complexity. So they define it's their method.
On the other one.
There is one article online which explains how they measure it. For example, if we have one piece of code that has 10 if-else or switch statement, the cyclomatic complexity will be 10. But according to them, the cognitive complexity is 1. It's like, because it's really easy to go through and understand what each block, what the code does.
Working with heuristics and estimates, as always.
So yeah, my second study, I wanted to figure out if some of those issues or technical debt items are paid back over time. Yes, which are the most, or which of those technical debt items are paid back more often, and what is the survivability of those issues? In other words, after they produce to the project, how much time they survive before they got fit. Here, I also analyzed projects by Apache ecosystem. And as we can see on the bottom chart are the project, and with the green line, it's what is the percentage of those issues that were fixed over time, and with the yellow, which of them are still open.
So Patrick is abandonware. The one on the
Oh yeah. But for the first two, I actually applied for the majority of them, but for the first two, I was able to find that Apache Nuts, the developers of the Apache Nuts, use SonarQube in order to measure the quality of the project. And on the other hand, JMeter is itself a SonarQube plugin, although they don't mention anywhere if they use SonarQube. Probably they use it.
And what's on the top?
Oh, on the top are the total number of
Issues.
technical debt item or issues, yeah, over the time in thousands. For example, we had roughly 20,000, and from them about 15,000 were fixed.
So the green is the closed.
Yes.
The green, yes, the green is the fixed, and the yellow are the issues that are still open.
Yeah, but fixed, but green could also be ones like invalid bugs or duplicates and all the kind of bugs get closed for many reasons, otherwise that they get fixed.
Maybe. The word fixed, it's not correct.
Okay, yeah, but
somehow,
those are anything closed is included.
Somehow
in there.
disappeared, but
How long the period you mentioned?
Oh, for those, actually I analyzed the whole history of those projects, and some of them they have about 10 years of history.
10 years. Okay.
Can I just ask, those projects that you've listed there, what are the nature of those projects? Are they
Open source.
they're open source
They're open
development
source.
efforts, are they?
Yeah, they are open source.
In other words, the development of the Apache system.
Yeah.
Right.
I mean,
And
the
also-
backgrounds are varied. Some of them are ex-corporate software, some of them are hobby
Functionality
things.
is all different types.
Yeah.
of things.
And another thing that they have common, all of them, they are Java projects.
Right.
I focus on,
Okay, sorry. Yes, the Java project.
I focus only on Java projects.
Yeah, fine. It just begs the question, why do you think that there's a massive range there where this one down the bottom pretty much hasn't been fixed?
Yeah.
I assume it's got problems and it hasn't been fixed. Is that what you're saying? And then at this end, there are some projects that a lot of the problems have been fixed.
Mm-hmm.
Why have some projects had the technical debt fixed and others not? Is it because they're regarded as being useful by people as applications, so there's an incentive for the developers to fix them.
I guess it's the effectiveness of the communities supporting them.
Is it? Okay.
And
So
their
that's
size.
interesting. Yeah. Okay.
There is a varied
Yeah. Okay, thank you.
developer community as well.
Yeah.
So these are total issues or only related to SonarQube kind of issues?
Yes, only
Only technical debt related issues?
Yeah, that's on detect.
Okay.
This histogram presents the distribution of the number of the fixed issues for its type. As we can see, every vertical bar represents one issue type, and the height is proportional to the number of the issues that got fixed over time. This is a strongly skewed distribution where a handful of issue times are fixed very often, very frequently, and very few of them are rarely fixed.
Would you be able to tell us which ones are the ones that are mostly fixed?
The most, okay, it's the next slide.
That's the next one, okay. Yeah.
This is
I thought it might be.
yeah, because these are the most issues with the highest fixing rate. So yeah, conditionally exclude blocks should not be read.
So it's code that's never executed.
Yeah.
There's code in there that's never
Yeah.
executed, so people take it out.
Yeah.
Or it was actually intended to be executed, so they change the path so it goes through it.
Yes.
So that's fixed.
Yeah, and after some time, they realize that that the code, so they fix up that type of issue. It's fixed about 60% or.
Right, but it seems like the Java doc tag, the third one, or that's a trivial fix. You don't have to think about it, you just add the tag. Whereas some of the tags, like conditional executed block, you need to first determine whether or not it should be executed. There may be a logic error.
In one of the beginning slide, you said the one with 10 minutes related to architecture. I mean, you don't need to go back. I just wondering, is this one I was wondering how this kind of architecture's problem can be fixed.
Architectural issues, yeah.
For each one of the issues, they have one description which explains how you could
fix it.
And that one.
But they are more low level rather than architectural.
Yeah, the most of them are low level source code issues. But yeah, they have the tag, they classified as architectural issues, so I'm not sure if it is. I relied on what they say.
Okay.
Yeah.
I just wondered.
What's interesting about that is that there's actually not much of a range there in terms of the number, the frequency. You know, it goes from 60 at the top to 50.
But
the bottom those are only the top 10, I think.
Yeah,
exactly. Yeah, they're the top 10 seem to occur with almost the same frequency.
They're being fixed
Right.
with the same rate. It's the fixing rate.
This is a fixing rate. Isn't
Yeah.
it? Okay. But how does that relate? The first graph is the occurrence rate. The occurrence of the problem, not the fix. That is the fixes.
Yes.
Yeah.
Okay. Right.
But that one includes quantity, and the other one doesn't include quantity.
Right. Thank you. How does that relate, do you think, to the ability, the cognitive quality of the code, if you like? It talks there about Boolean expressions not being gratuitous. There's an element of subjectivity in what's gratuitous and what isn't. Do you see what I mean? If those problems were fixed, do you think that people would regard the code as maintainable?
It's more maintainable.
Well, obviously it is, but is that regarded as where do you stop? Because you could, there's bugs in all code, isn't there? You could carry on down that curve until you got to, the occurrence that is very, very unusual. But how far do you think, if you were if you were trying to create something that was usable quality or maintainable, if you like, which of those, where would you?
Those are the most.
Where would you instruct your software engineers to stop?
Okay, yeah, I see. Those are the most frequently fixed. Does not mean that they are the most the most important.
Okay.
Maybe they are the easiest to fix.
Yeah.
Yes.
Some of them are certainly very easy to fix.
Architecture.
Well,
The
yeah.
override
Yeah, exactly.
annotation you can do
I
automatically.
understand what you mean.
Yeah.
Is Paul is saying that those are the easiest ones to fix. Therefore,
No,
those
no,
are-
the first one is actually not that easy. So there's different difficulty of fixing them,
Well,
but they tend to be really easy to fix.
So into Eclipse, it'll tell you if there's code that isn't actually running.
Yeah, no, but you have to think about what it does. Whereas the override annotation, you can have a computer do it for you.
Right. Thank you very much. Yeah. Good one. Good point.
So yeah, those I think are maybe the most important issues whose the resolution has yielded the highest benefit. In other words, they paid back the most of the technical debt.
Right.
Yeah, if you get rid of the duplication, or if you make your source code less complex, and if you handle properly the exceptions, then yeah, as you can see the top 10, then I think the quality of the project will increase much more. At least it will be easier to, more maintainable.
Well, that's the difficulty. What do you mean by high? What's the criteria for higher benefit? And is that related to what you've previously said, or is that a new thing now? The higher benefit.
Okay, yeah. I'm not sure about if it's a proper word, but what I mean here is I calculate how much technical debt was paid back.
Right. And that's regarded as higher benefit.
Yes.
Yeah.
So why would removal of commented out code have a -8 there? How does that work?
Oh, okay. That is how this thing changed compared to the first study.
It's not a minus, is it? Is that regarded as?
This is
It's gone down 8 places.
Yeah, change in the ranking. It used to be
change in
the
rank.
rating.
Yeah.
Right.
Okay, so how they moved? Okay, yeah.
How they moved,
Yeah, so there's not.
So yeah. How they
So for instance, to fit the first fault about removing duplicated blocks is by replacing with a function or something. Is that what you mean? How would you remove a duplicated block? It's a block that's actually executed but repeated somewhere, and then you could
copy paste
use
code.
I could put it into a function or into a class or something.
So yeah, maybe you can extract a function or something.
Yeah.
It tends to improve the quality of your code if you get rid of it.
And the other thing about the cognitive complexity is that is also a little bit subjective, isn't it? I mean, one man's sort of nicely written, succinct bit of code is another man's complex nightmare to be able to unwind what it's supposed to do. You know, how do you know that something is regarded as complex? You know, a loop within a loop. For instance, some people would say, "Oh, that's good practice." Other people would say, "That's not good."
But maybe it's not clear how they calculate. They have one threshold. Let's say upper than 5. It's a bad thing to have cognitive complexity more than 5.
Okay.
So online there's documentation.
There's ways of rating it.
Yes, how they use.
Okay, so obviously well known. Okay, thank you.
This figure shows the distribution for each one of the 10 issues.
What do you mean by survivability?
Oh, how long they were existing in the one project.
Okay.
So what's the unit of duration? Years or days?
Yes, here are number of years.
Years.
Ah,
Okay. Yeah.
So
So
yeah.
So the duration of the project.
No, the duration of after
The
one
bug.
a bug or in type of
Okay.
issue was produced.
Right.
I track how long it lives before it fixed or somehow disappear.
Oh, that's fascinating. Right.
So yeah, some of them they were fixed about in the first month. The majority got fixed the first year, but there are also some types of issues that exist more than 10 years after the introduction.
Or not yet at all. Or not fixed yet.
Yeah, that is what it means. They have not fixed it yet. They have not been fixed yet.
At least at the time so many.
So the takeaways of that study is that there is a variation in the fixed rate of the issues. About 10% of the issues are fixed in the first month after the introduction. 50% of the issues were fixed in the first year. But also, as we saw, some issues can take more than 10 years in order to be fixed. And issues related to duplication and exception handling are frequently occurred and encountered, but rarely the developers fix them. In this slide, I have already mentioned, but I'm presenting the limitations of my two studies so far. I relied only on open source project by Apache Software Foundation. I analyzed only Java projects, and I used SonarQube at their way of measuring technical debt. I took only weekly snapshot for each one of the projects. The architectural decisions were not known since they are open source, or I was not able to have access to them. And for some of them, I'm not sure what the commit policy they use. I was analyzing, I don't have it on my slide, but I was analyzing one project called Apache Jena, and they had a 90% fixing rate. That was amazing. So for that one, I contacted the developers of that project, and I asked them, why do you have so high fixing rate? Do you use SonarQube or what do you do? And the guys replied to me that it's the commit policy that we use. Everyone who commits in that project goes to the main branch. And he also explained me that there are also some projects, some Apache projects that have different commit policy. For example, every commit has to go through one or two reviews in order to go to the main branch. So, yeah, maybe that's also an explanation why there is so much difference on the numbers from one project to the other.
But is it typical that the client would have the requirement that the code meets these criteria? I mean, as a client, for example, I'm a client for a product, and I would tell the company, would you make sure that the code is well written and those technical depths are not there, or those whatever? Is it typical to ask them to access to that, the system that you were describing, the SonarQube? Yeah, is that something acceptable in the industry now? To ask the software company to provide a report from SonarQube about.
I think it's not common practice to do this as a customer. Might be beneficial, but only if you want maintenance. Because normally, if you want a product, then you only care this is delivered for that amount of money. Of course, later on you want the quality of the product or the maintainability.
Yeah, but that costs them anything to run the codes through the SonarQube and send you the report after.
But getting it better scores on SonarQube might be more expensive to program.
I understand that, but at least
So as a customer, you end up paying for it some way or another.
Oh yeah, it's the old adage, isn't it? You're paying me now, you're paying me later. You know,
Yeah.
if you send something out with bugs in it, you're going to get feedback from your customers saying this don't work, and you know, fix it.
Well, this is what I'm saying. So at least to
Yes,
be
good
transparent from the software company to say, well, here is a report according to these best practices.
Normal software engineering practice is that, you know, you don't write rubbishy code because your colleagues will give you rubbishy code back as well.
Yeah, that's right. But some of them would do because they have the contract which is 3
You are
months old.
currently
a big issue.
Apache open source. If you analyze other platforms such as I don't know whether it could go to GitHub, is there any possibility you're thinking about the difference? From funding, from what you found.
What you mean, other than the open source projects?
Yeah, the other platform. This is
But
only Apache.
it's getting the data, isn't it? That's difficult.
If you GitHub, you can.
Probably I will have different results. Also, I forgot to mention on this slide I have this symbol here. Those are issues that are Java related. All the others are the others are language agnostic. So we can have on the other programming paradigms or other programming languages.
Say one of the things, I'd say your results shouldn't be replicatable through GitHub or for commercial software.
Yeah,
they tend to have different practices.
Yeah,
and GitHub, you have a lot. Say to get into Apache, you need to meet some kind of a hurdle. And GitHub, the only hurdle is to create an account. So you just dump it on GitHub.
Yeah, actually, I analyzed software by Apache Foundation because that's all they are publicly available, so I have access. And also they have high quality, so I wanted to figure out what types of issues on the project that almost everyone admits that are high quality. And then maybe I can use it as a benchmark in order to, if I analyze properly the software.
Have you had a look at the architectural technical depth in some of the projects? Or thoughts about how to find out that there was something fixed about it?
Something related to the architecture?
Yeah, I mean, it might be that if they make a big architectural change, you might see that in the size of the commits or something like that.
The problem is that I don't have access to that information. I don't have access to architectural documents. Also for some of the projects, the architecture maybe.
Yeah, but there's an architecture that actually lives in the source code.
I'm not
seeing that it changed might be checked, but if you see classes that are changed a lot, that might be a change that they are doing some refactoring for one reason or another. Then look at what's going on here. They say, oh, there's an architectural change.
But that one would be more difficult for me to detect. I should have someone.
You wouldn't do it on every project. You would do it on one or two.
Yeah, if on 1 or 2 years, I think it would be a good idea.
So where do you take this work now? What's the next step?
Okay. So what I'm trying to do now, I think it does not make sense to focus on what type of the issues that you have that exist already on your source code. Try. It's a different slide. Okay, this one says that the quality, as we have already seen, the technical debt tends to increase over time. But however, for many of the Apache projects, the normalized technical debt, the amount that exists on each line of code, tends to decrease. So, I would like to figure out when the normalized technical debt is decreasing in one project. This is because technical debt is paid back, or the new source code is clean, and the code base becomes bigger, and that's why both.
Yeah, it's a good point because you've got two things going on there. I mean, in the first case, you've got bugs being fixed, but when you get to the point where the bugs have been fixed to the extent that you're actually beginning to degrade the quality of it again, it's coming to the wear out phase, if you like, that I think you mentioned in the previous slide. Just go back.
Another thing, I think.
When the project degrades over time, then it's not improving, is it? The point is, it improves at first because of the technical debt problems are being fixed, but then it gets to the point where the fixes actually degrade the code. Is that what you're saying when you say the project degrade? What is leading to the project degrading over time?
Okay, what I mean here, it means that technical debt tends to increase over time.
I know, but why? At what point do you make the determination that it's worth putting effort into this piece of software to reduce the technical debt, i.e. fix the problems, and then there comes a point where it's not worth fixing anymore because it's degrading. The work that's being put into it is degrading it.
I think that there is actually a problem that if you just leave the code alone, you will accumulate technical debt, because some of the technical debt will be contextual. There may be new language versions, new library versions that you interact with, where new best practices that come in. SonarCube goes and detects that, and you have more. But in reality, not only SonarCube, the reality is that, if you use a 5-year-old version of the language, then you can't integrate it with your other software that's more modern.
Okay,
therefore, the software needs to be fixed there to be usable today.
Issues? There are other issues. They're not in the taxonomy that you introduced earlier on. You know, like pieces of code that are executed and wrongly named function names and what have you. Those problems are the problems of long-term maintainability. This is what Paul's talking about. So in some ways, the reason for the degradation is different and distinct to the reasons that you previously talked about.
There's environmental degradation.
Probably need looking at to find out what they are in more detail to be able to justify your comment there that the project degrades over time.
Yeah.
You know, because previously you've been saying that this is actually improving.
Yeah, actually.
Exactly. I don't know what you mean by normalizing. Over, you mean the technical,
not common lines of code. Yeah.
Right. But it must become a point where it reverses. Otherwise, it would never stop improving, would it?
I mean, the thing is, especially the ones that degrade are the ones that don't really have too much maintenance on. But anyway, let's go on.
So that is what I'm working now. I think that might be huge value in trying to get rid of existing technical debt. I think the developers should aim at writing technical debt-free source code, and also there are reports like companies like Google. They replace their code base. They replace 20% of their code base every year. So what it means if the newly set source code is clean after 6, 7, or maybe 8 years.
There's probably 60% of the code base that's touched, and then the other 40% never changes.
Yeah, because nobody understands how it works.
sometimes. Or because it's rock solid.
Yeah.
Either happens.
Still an interesting thought. I agree.
But I think there's still the introduction of technical debt through evolution of expectations and standards. Then that will mean that you will not. The technical debt will be introduced. I think it would be interesting to introduce it as a separate category.
Yeah, I think the other thing that you could add to that is that additional different technical debt features come into play as code ages. Not the original ones the original ones that are found on release are the categories that you talked about.
But by
the ones that begin to come into play when a piece of code is being used for 5 years or something is the issues that Paul talks about, like how compatible is it with current operating systems and things. Sorry, if we short time.
Yeah. Just go continue.
Okay.
No,
Yeah.
we can talk afterwards, but
Yeah.
we have only 5 minutes for the room.
I've got a seminar to do actually,
Yeah.
so I better go, and then you can get on a lot quicker.
Yeah.
Thank you very much.
Thank you. Thank you.
Really interesting. Thank you.
Thanks.
So yeah, I would like to figure out if the sloppy code got removed over time, if the removal happened intentionally or accidentally, or this side effect, and if the newly set code is cleaner, it's not totally clean, then what type of technical debt issues it produces, and if the normalized technical debt of the new code is smaller than on the projects that tend to do over time. Okay, I don't know. Yeah, thank you.
I think last time in the you mentioned a little bit how the introduce the Sonic code.
SonarQube.
SonarQube into the different project.
How?
How to use the SonarQube into the different exist project.
How do you
Last
know?
time you mentioned a lot of about the SonarQube.
Oh, okay.
Yeah.
I lose you.
Last time when we were in Shanghai,
Yeah.
you talked about how to SonarQube. You can go in more introduce a little bit more about the SonarQube.
How it works?
How it works, and how you can put your the project.
Oh, okay, yeah. First of all, as I mentioned, it's open source.
Did you ask for 2 hours, only 1 hour?
I asked only one.
Yeah, very
Sorry.
little time.
No, basically the reason why we are invited George here because one of our project is going to develop something. That's the reason why we would like to have the pre-clean and the thing and so on. Yeah. So you give a lot of demo about how to the SonarQube. If you remember last time, you also give all the SonarQube in the C++.
Yes,
all
yes.
You can introduce a little bit about that.
Okay.
Just shortly.
Yeah, I think
5
that is
minutes.
good. So first of all, it is here. Okay, it is one list of the supported language and plugins that you can install. For example, if you would like to analyze, for example, a Lua project, then what you should do is to install the plugin, and if you would like to analyze a C++ or whatever, you should install that plugin. And then, in order to use it, they have one thing which is called Sonar Scanner. You have to install it on your computer, then to point the root directory of your source project, and then that one starts the analysis of the project. First, it downloads the plugins based on the configuration, starts the analysis, and then it puts the results into this platform. And then you can analyze multiple versions of the project. For example, here I have analyzed from 2007 almost till now, yeah, till July, yeah, maybe July 27. And I have analyzed each commit of that project. Here, those graphs show how the number of what was the actual number of bugs, code smells, and vulnerabilities on that specific commit. And also here, let's see, we can see how the number of the lines increase from one revision to another. Also, I think the number of the issues. How? So for here we can see, maybe one part that is interesting how this thing went from this one or to this one. Maybe they were having a maintenance cycle or something like that. Or here, which is a big decreasing in the number of the open issues, which looks like a refactoring phase or something like that.
That's how you can say, look at your architectural changes. One thing I
Yeah.
was thinking was also, one of the things I was also thinking might be interesting is a lot of these projects that are either using Maven or Gradle, you actually know their language versions, you know their library
Yes.
dependencies. What would be interesting to see is what the density of commits is when they change those versions. So how many lines of code are actually changed to be able to support this next version? If you use this project versus that project with the same library change,
Oh yeah, I see.
there may be some interesting thing you can get out of there. It might be an indication of how much technical depth was there before you did the change
Actually, now I'm
on
analyzing.
an architectural level.
Yeah, actually now I'm analyzing only Maven projects. Yeah, because I was able to have access to that kind of information, what libraries they use, which JDK version they need to combine.
Yeah.
It's also a good idea to figure out what happened from one revision to another in the POM file, and if they introduce one library or what they did.
Yeah. How much change is
How
occurred,
much, yeah.
especially changed lines rather than added lines.
Coming to it from a different perspective, very quick question. I'm coming from software requirement engineering perspective, transparency perspective. What are the rights of the clients to see these, and also to see something like Jira or the other, to see who is working in which task now, and what piece of code, who is committing these changes? Is it common practice now in industry that the client, not the software engineering team, have access to Jira type of tools and that kind of things?
I think it depends on your client. Yeah.
The
So we
one-
have to go.
We need
Sorry,
to
sorry.
go, yeah.
But
Offline,
Yeah,
switch
we
off.
are.
Yeah.
but